Welcome, everybody. My name is Josh. I am a solutions architect here at Pulumi, and with me is Tim Hyatt. Tim, if you would like to introduce yourself.
Hi, everyone. My name is Tim Hyatt, and I am part of Google Cloud's professional services team. I am a technical solutions consultant. I spend a lot of time with customers, and I'm looking forward to presenting with Josh this afternoon.
Awesome. And we'd like to welcome you, by the way, to getting started with Kubernetes on Google Cloud with Pulumi. All right. So before we begin, a little bit of housekeeping. Comment in the chat. It is easiest if you use the Q&A tab to ask your questions. That'll help us keep track of them, and just in case they scroll out of view, we don't want to miss anything. Um, Definitely encourage everyone here who's interested in learning about Pulumi to join the Pulumi community Slack. It's one of the best resources that exists for helping to learn Pulumi. There are plenty of folks in the Google Cloud channel, including Tim. I am also in there, as well as a good number of Pulumi staff members. In addition to the staff members of both Google and Pulumi, we have a very, very engaged community, and you can ask pretty much any question, from like very, very basic usage to like advanced things, and you'll get really good answers from the community. Their code for everything that we are presenting today. There's a link for that in the handouts tab. Something went weird with us on GitHub. And so my code is still stuck in a PR for the moment. But if you watch that PR, just subscribe to the PR and it'll let you know when it's merged. But you will definitely be able to see the code there because it's a public repo. So again, go over to that handout link. And the code will be there and it will eventually be merged. Just watch the PR and you'll be notified when it's merged. Feedback is always welcome. Let us know what works, what doesn't work, what type of content you'd like to see in the future. Again, please use that Q&A tab to let us know if you have any questions. Oh, one more thing. You will get a recording of this presentation. You'll get an email with a link to this presentation on YouTube. So if you want to rewatch and follow along at your own speed, that will be available to you within a day or two. Some of the prerequisites for the stuff that we'll be doing today: you'll need a Google Cloud account. You'll need to install the Pulumi CLI. You'll need to sign up for a Pulumi account. Pulumi is open source, and we'll be using the Pulumi Cloud backend, which is the easiest way to learn Pulumi. The Pulumi Cloud backend will be storing will be doing your secrets, encryption and decryption, and storing your state file. The Pulumi Cloud backend is free for individual use forever. So if you're learning Pulumi, this is definitely the easiest way to do it. There are some additional options when you're adopting it like an organizational level. So you can use Google Buckets object storage to store your state file, and Google Secrets Manager, I believe, to do your secrets encryption. And we can get into that a little bit later if folks are interested. For the code that we are writing, you will need to use. So I'm using Node 19 and TypeScript 4. That may not be the minimum requirement, but I know that it definitely works. So if you're somewhere around those versions, everything should work fine for you. And if not, just update your Node version. Okay, and I'm going to hand off to Tim to talk a little bit about Google Cloud.
Cheers. Thanks very much, Josh. And hello, everyone. Greetings again from myself. This show is mostly going to be run by Josh this afternoon. Going to look at some awesome demos on Google Cloud. But I do want to take a moment to tell you just a little bit about Google Cloud itself. First of all, keep your cursors in the chat. Maybe you can just answer a few questions so I can see a bit of two-way here. Is anyone using Pulumi at the moment on Google Cloud? Like just a simple Y or a yes or an N for a no, anything. You can spam the chat in this moment. That'd be great. Just as I talk, so I get indication. The reason I ask is while we're specifically going to be using Google Cloud, we're going to be talking a bit about Kubernetes and containers, which is really going to lead me into the start of the presentation. Awesome. Couple of yeses, couple of no's. Awesome. This is great. Thank you very much. Okay, so let me tell you a little bit for those of you who haven't spent any time using Google Cloud or understanding Google's kind of network infrastructure. Keep it super high level and not super boring. But for those of you who understand cloud infrastructure and cloud regions, Google itself operates cloud regions in 37 locations. This is continuously growing. We've got more regions opening up later in the year, some that have been announced, some that will be announced. But what's really interesting is we have these regions, we have zones, which is when you have a data center or a region in Paris, for example, but you actually have multiple data centers in Paris. So you enable yourself for disaster recovery or outages or failover within a region. But most importantly, we operate in 200 countries. And while I'm talking about this from like a Google Cloud point of view, I think it's interesting to say specifically that Google actually operates the largest or one of the largest private networks in the world. Why is this important in regards to what we're talking about today? Is because we're going to be focusing on Kubernetes. Therefore, we're going to be focusing on containers. And the reason I want to talk about the network infrastructure of Google and Google Cloud first is because everything at Google runs in containers. On average, within Google as an organization, within Alphabet, we launch several billion containers every week. We treat our infrastructure and most of our applications and content as immutable containers. They run, they live for a short period of time, they fail or die, we kill them deliberately. We treat everything as a container, and we try and run as much of our core applications in containers as possible. What does this mean for an end user for Google's products? Well, to me, that's really interesting because when you use our products, you may not necessarily think of containers. Let's start with what it looks like for Google. So Google Maps, Drive, Gmail, Meets, YouTube, Photos, the App Store that your Android phone interacts with, all of these objects, all of these things that are running on Google's production network that I was talking about before in those regions is actually being run in containers and being run at scale. So our core network serves all of our billion scale applications in containers globally, every day, 24/7. What do we mean by billion scale applications? Well, at scale, billion scale, that is billion user. So the applications that have billions of users every day. What does Google Cloud mean comparatively to the Google network? Well, Google Cloud is our public offering that allows our customers, that could be you, that could be other people that you know, sometimes in my personal life, it's even me, to use that same core network that we run YouTube, Gmail, all of those things in, to host your own applications in the same platforms that we use. And in Google Cloud, we basically operate three or provide three primary methods for running containers at scale. That's GKE, Google Kubernetes Engine, and GKE Autopilot, which is a very cool addition to Google Kubernetes Engine that actually abstracts away all of the management of the infrastructure and leaves you with almost a completely serverless operating environment for Kubernetes Engine. And then we also operate Cloud Run, which is specifically designed to run single containers at scale. Okay, I'm just looking at the chat as we go along. Are we all okay with the video again? A container died. That's actually a very funny joke. Well played.
Yeah, Tim, you're unstuck now.
Cool, awesome. So sweet. So there are three primary offerings inside Google Cloud. Google Cloud, as I said, runs on our billion scale application core network, which has got this awesome global reach. And the reason that we offer this content in this way is because, well, Google has more than a decade of experience at running containers at scale. So this is a little timeline for you. It's very heavily abstracted away, but from the formation of the modern concept of a container, and I do say the modern concept of a container, was open source by Google back in 2006. And when Kubernetes as a project, an open source project, was unveiled, Google then quickly released GKE several years after that. And now we have GKE Autopilot and Cloud Run. So we've been doing this for a long time, and we're doing our best to as rapidly put it into the hands of our customers, people like you who really want to take advantage of containerization and ultimately serverless running of those containers. So scalable applications, like the ones that you are building, like the ones that we are providing on the open market, Gmail, Meets, etc., they require scalable infrastructure. We have this huge network at Google that is global, but it's not necessarily just easy to manually set up all of your infrastructure and deployment one step at a time. And so we need scalable infrastructure. We need infrastructure as code. And specifically today, we're here to talk about infrastructure as code with Pulumi. It's one of several offerings on the market, but it is a fantastic offering, hence why I'm here and wanting to talk to you guys about how it works with Google Cloud. So just like a couple of brief notes on like why infrastructure as code and why Pulumi. And infrastructure as code, for those of you who don't know, is designed specifically to make the deployment of your core infrastructure in the cloud simpler and more efficient. You can write out the actual implementation of your VMs, your Kubernetes, your network, your permissions for users and access, your service accounts, all in code, execute it, and have that actually served up in your cloud environment in Google Cloud. It embraces the best practices for deployment of immutable infrastructure, i.e. can only be changed by a modification to the code and then ultimately a deployment by a secure pipeline. It also means that you get the auditability, which is super important if you are operating in a highly regulated environment. I've been living in Germany for several years. I've been really learning a lot more about data regulation, but also independent local regulation that is different from country to country. And being able to automate those policies and those security components that are compliant with your local legislation, but also your organization's own policies around data protection and customer protection is really quite a simplified process when you use infrastructure as code, because it's really easy to audit what's happening. You can check in all of your code into source control like GitHub or your own on-premise source code repository system, and then you're able to track every change that's made not only to your application code, but also to your network, your infrastructure, your repositories, your permissions. And this is of great value, especially in a regulated environment. Plus, you get the security of being able to deploy all of that infrastructure through pipelines that only have specific permissions. And this means that individual users won't actually have the grants to create a cluster here. They have to write the code. They have to run through an approval process, pull requests, 4, 5, 6 eyes, depending on your organization. And then finally, it will be deployed automatically. And this is where like Pulumi really comes into play, because Pulumi as an infrastructure as code provider, like it's enterprise ready, has a whole bunch of functionality out of the box that helps with policies and automation and team-centric kind of development of your infrastructure and your application. And it takes on a lot of the real-world best practices of Google Cloud's like professional services teams, like myself, who are 100% adamant that the safest way to do kind of deployments of your development, test, and production environments is to do it with something as controlled and audited as infrastructure as code. What else is cool about it? Infrastructure as code allows you to get documentation for free. Your code becomes the documentation. You can read your code. You can understand what it is you want to get out of your infrastructure, and what you write in that code is what you get. Additionally to that, it's repeatable and recoverable. One of the coolest things I've ever seen, or I see on a regular basis actually, is working with some of our really large scale customers who have developed their entire environment in code, like with infrastructure as code. And they have their DR in one region on our global network. Let's say it's in Belgium, and they have their main operating environment in Frankfurt or even in Stockholm. and they're able to fail over from one region to another super quickly because the code is the same, but the deployment region is the only difference. And so it's repeatable, it's scalable in that manner. You could start as a small organization who needs to move to multiple regions, and it's as simple as saying, I want to take the current definition, like my code, my infrastructure as code, and I want to deploy it to a new region. And with a little bit of configuration for the networking in between, like our global network and our resources in our data center are able to be provisioned just by a redeployment of that code. And I think that's like a really like fantastic use case for infrastructure as code, as opposed to this old school way of like manually writing every command and storing them in a notebook and hoping that you don't need them again. Like the world has changed, and infrastructure as code is like pivotal to almost every organization who automates their deployments to the cloud today. So I've touched a little bit about infrastructure as code and why infrastructure as code. And we're going to show you why Pulumi is like super powerful for utilizing this. And so I'm going to pass it back to Josh now, who's going to tell us a little bit about Pulumi.
All right. Thank you so much, Tim. That was great. So about Pulumi. So the first thing is that like you definitely want to create a Pulumi account. It is totally free. It is free for individual use forever. Again, using the Pulumi cloud as your back end is going to make learning Pulumi as easy as possible. Once you think you might be ready to adopt Pulumi at an organizational level, that's the point where you might want to consider signing up for a free trial. It's 14 days free. There's no credit card required, and it has like all of our most advanced features. So you get the full suite of our feature set. That includes like organization-wide policy as code, which is very helpful for the use cases that Tim described, where you're dealing with a lot of where you have regulatory compliance. It also has like all of our organization like user management features such as SSO and SCIM. So again, sign up for Pulumi account now if you haven't done that. Use it to learn Pulumi, and then when you are ready to consider adopting it at an organizational level, you might want to sign up for a free trial. Okay, so what is Pulumi? Well, Pulumi is universal infrastructure as code. And so what do we mean by that? So first off, Pulumi supports a wide range of different clouds, including, of course, Google Cloud, the other major public clouds, but we also support a huge list of other like smaller cloud and SaaS providers. So some examples of other providers, we have GitHub, GitLab, we support Datadog, New Relic, you name it, we probably have a provider for it. And you can see the complete list of our providers over at the Pulumi registry. And I'll try to get a link to that in the handouts shortly. In addition to being able to be used with multiple clouds, you can also write Pulumi code in a range of languages. We support, you'll see the full list of languages very shortly. So the unique aspects of Pulumi are essentially that you can use it with multiple clouds, but also use real programming languages. A little bit about Pulumi's like the program model. At the outermost level, you have a Pulumi project. You initialize a Pulumi project with the Pulumi new command, and I'll be demonstrating that very shortly. So we have our project. Within our project, we have our program, and today we'll be using TypeScript. So your Pulumi program is in your index.ts. Within your program, we create resources. So some of the resources we'll be creating today include a network, a subnet, and then we'll be deploying a GKE cluster into that subnet. And within your resources have inputs and outputs. So for example, we are going to create a network. The network ID, so the network, it might take the CIDR block, for example, as an input. And so the CIDR block, the network will have an ID output. We will use that ID output as an input to the subnet. And again, I will demonstrate this in detail shortly when we get into the demo portion. And so when you use Pulumi, you have this pattern of like creating resources, and the output of one resource becomes the input of another resource. And what's going on behind the scenes is that Pulumi is keeping track of the dependencies between these resources. And so that's what enables Pulumi to be declarative. And so, for example, so what do I mean when I say declarative? It means that you only have to describe your desired state of the infrastructure that you want, and Pulumi will figure out the steps that are necessary to make it the way that you want it. So if we create a GKE cluster, and we declare that we have 3 worker nodes, and then we tell Pulumi to update our infrastructure to make it so, we will have a cluster with 3 nodes. If we change that to be, say, 5 nodes, we don't have to explicitly say add 2 nodes. We just declare that we want 5 nodes, and Pulumi will figure out, oh, I need to add 2 more nodes to the cluster. So in that way, Pulumi is declarative. So in addition to our program, we also have stacks. And stacks are essentially instances of our Pulumi program with different configuration values. So a very common scenario is we might have a dev stack, a QA stack, and a prod stack. And we might set different configuration values in those stacks. So we might say we want 3 nodes in our dev, or maybe we want less powerful worker node types in our dev environment. And we can use the same program with different configuration values to deploy, say, a more powerful cluster in our prod environment that we might have more nodes or more powerful nodes. So in that way, you can use Pulumi stacks to stamp out identical copies of the same infrastructure using the same Pulumi program. I see that we have a question on the Q&A. I will get to that question a little bit later. So a little bit about Pulumi's physical model. So in the bottom left of this slide, you will see that we have our Pulumi program. Pulumi supports a range of languages. We have Python. We support Node, which is both TypeScript and JavaScript. You can write Pulumi in Go. We support .NET, which includes both C# and F#, and even Visual Basic .NET, if anyone out there is still using that. And we also have Java support, which is in preview. And we also have an option to use YAML. The YAML option is used mainly for very large organizations where you might have some folks that are more comfortable using real programming languages, but other folks who maybe come from a more traditional ops background and still want to use YAML to create infrastructure. Your Pulumi program is executed by the Pulumi engine. That's the CLI. And so what the engine does is it looks at your program, and it looks at your Pulumi state file, and your Pulumi state file holds the state of whatever your infrastructure is in the cloud provider. So in the example that I gave before, if your Pulumi program says 5 nodes and the Pulumi state file says 3 nodes, the Pulumi engine will figure out the difference between those two and know that it has to add 2 nodes. And the way that Pulumi creates and manages resources in the cloud is through Pulumi providers. So in this diagram on the bottom right, we have the Google Cloud provider, which we will be using today, and the Kubernetes provider, which we will also be using today. And those providers are what make the actual API calls to like create, update, or delete resources in the given cloud. So, for example, the Google Cloud provider will be making the API calls to the Google Cloud APIs, and the Kubernetes provider will be making the API calls to your Kubernetes cluster's control plane. I'd also like to mention that we have a new feature called Pulumi AI. We will be demonstrating that later today. It is a wonderful, wonderful way to learn Pulumi. It is powered by ChatGPT. For folks that aren't familiar, ChatGPT is part of a new generation of AI technologies called large language models. And as you'll see later on, you can enter a plain text prompt in Pulumi AI. You can select a language, and it will generate a Pulumi program for you, which you can then iterate on, which again we'll see shortly. It is free for everybody to use, and there is a link to Pulumi AI over in the handout tab. All right, so it is now demo time. So I'm going to share my screen. And I'm going to shuffle some windows. Okay, and we should, everybody should be able to see my screen now. I will try and make that a little bit larger. Hopefully that is large enough for folks to see. Can I get a little bit of feedback in the chat? Is this large enough for you to read? All right, it's good for Tim, and hopefully it is good for the audience as well. Okay, so the first thing I'm going to do is initialize my Pulumi project. So I'm going to do that using the Pulumi new command. And you'll see that when I execute Pulumi new, I'm getting a list of templates. These templates are all starting points um, for a Pulumi program. So we're going to use one of our newer templates today. We're going to use Kubernetes GCP TypeScript. And so we're going to select this, and we're going to be prompted for our project name, which the default here is fine. Our project description, again, the default is fine. And it's going to ask us for a stack name. And then we're going to get some configuration options for the GKE cluster that it's going to generate. One node pool per zone. One node per zone in the node pool is fine. And then we're going to ask us which project we want to deploy into. So enter that. And then the region, US Central 1 is close enough to me. And then you'll see this output that should look very familiar to anyone who has done any node development. This is NPM, Node Package Manager, installing our dependencies. And now we have ourselves a templated Pulumi project. So I'm going to explore these files a little bit. Okay, so first we have our node modules folder. Nothing exotic here. It's very standard for folks that have done any node development. I have a git ignore file, which we can skip. And then let's come down to this index.ts. So this index.ts, which Pulumi has generated for us, I'll go through this line by line shortly, but this is the entry point to our program. This is where we're defining resources, and this is what the Pulumi engine is going to run to create our infrastructure. We also have this Pulumi.yaml file. So this is our project level configuration. You'll remember that when we were running Pulumi new, it prompted us for some stuff, like, for example, the name of the project. And so that content is stored in Pulumi.yaml. We also have this file, Pulumi.dev.yaml. So you'll remember that when we ran Pulumi new, it was asking us to create a stack. That stack we called dev. And then it asks us some questions like how many nodes per zone and what project and what region. And those configuration values go in our stack configuration file, which is called pulumi.stackname.yaml, which in this case is dev. And so like you can see that if we had, for example, a QA stack and a prod stack, we would be able to configure it differently. We might want to deploy to a different region or a different project or have more nodes per zone. And so we can do that via these stack configuration values. So I'm going to take us into index.ts, and we're going to go through this pretty much line by line to explain what's going on. Okay, so first, we're going to import the Pulumi SDK. That is at pulumi./Pulumi. What does that give us? Well, that gives us like basic non-cloud provider specific functionality. Like, for example, the ability to pull from our stack configuration file, and that is done using pulumi.config. So, so for example, we have in our pulumi.dev.yaml, we have this GCP project defined, and we are pulling that value from our config file and putting it in a local variable, which we will be using later on in this program. So that is what the Pulumi SDK brings in a lot of other things, but it's essentially it's where you have all of your Pulumi specific methods and classes and things like that. In addition to the Pulumi SDK, we are also bringing in the GCP provider, and so this gives us access to all of the Google Cloud resources, like for example this network that we are creating here. So that covers both of our import statements. So in this block here, we're just grabbing values from our configuration file, like for example our GCP project or our nodes per zone. And then as we get down here to line 13, now is the point where we start creating resources. So what we're doing here is we're creating a Google Cloud network that is in gcp.compute.network. The first parameter here is the name. And so all Pulumi resources follow this pattern. We have the name as the first parameter, and then the resource options as the second, the resource inputs as the second option. And so you'll see this pattern repeated over and over throughout this program. So the first thing we do is we give our resource a name. It's important to know that the name is definitely required and needs to be unique for the type of resource. But internally, Pulumi will also, when it actually creates the physical resource in Google Cloud, it will add on a random string to the end. And so why does it do this? Well, and by the way, this behavior is overridable. So if you want to give it an explicit name and have it be exactly the same every time, you can do that. But we normally want auto naming because it will allow us to deploy the same stack into the same environment so that we don't have naming collisions. And that is a very useful feature. So when we create our network, we're going to say auto create subnetworks. That's fine. Or we're not going to auto create subnetworks. Next, we're going to create a subnetwork. And you'll notice here, like as I mentioned earlier, so we have this resource, this GCP compute network. We have inputs like auto create subnetwork, which you can see here is of type pulumi.input of Boolean. And we are using the output ID as an input to the network to which we are going to create our subnet. So hopefully that's clear to everyone. So again, you see this pattern of one resource's output becomes another resource's input. And then again, behind the scenes, Pulumi is keeping track of all these dependencies. And so it knows what operations need to be done in what order. After we create our network and our subnetwork, we create our GKE cluster. And so we have, some DNS cache added on as an add-on. We have a bunch of other configuration options that I probably could not explain in depth one by one because there's a number of them. Because we are, of course, dealing with Kubernetes, and Kubernetes is not it's not a trivial tool by any stretch. And so we have all of our cluster options, and then we're going to create a service account here on line 67, and we're going to create a node pool for our cluster. We are going to template out our cluster's kube config using some of the outputs from the cluster. So you can see here that we're using the CA certificate output to go into the kube config and a few other properties of the cluster. So we make our cluster kube config. And then finally, you see these blocks that are exports. And so what are these? Well, these are Pulumi stack outputs. Stack outputs they serve two purposes. In either case, they are allowing you to access values in your Pulumi program from the outside world. Excuse me. In the first use case, and which is what we're going to be demonstrating later, you will be able to pull these values from the command line using the Pulumi stack output command. And again, I'm going to demonstrate that very shortly. You can also use stack outputs to reference those values from other Pulumi programs. So when you start using Pulumi at a little bit more scale, let's say that you have a network team who are responsible for defining all of your network components, and maybe you have a platform team who are responsible for managing your Kubernetes clusters. You might use these network outputs. You might reference these outputs via what's called a stack reference from a different Pulumi program that actually creates the clusters. However, today we will be doing everything in a single stack. Okay, so that covers this line by line. Are there any questions so far on the contents of the Pulumi program? And I will give it just a second.
None in the Q&A so far.
Okay.
But if they come through, I'm keeping an eye out for you. And nothing specific in the chat.
Great. Okay, so the way that we create our infrastructure or update it is by running the Pulumi up command. That's going to run. And the first thing that Pulumi up is going to do is it will give us a preview of what it intends to do. Because this is the first time that we are running this program, everything is going to be a create. But you can see here, there's the list of resources that we're going to create. It will be creating our dev stack, our network, our subnetwork, our cluster, our service account, and our node pool. So in addition to that, you can see here are the outputs of this stack that it intends to create. And we're going to perform this update. We're going to say yes. And so it's going to do its thing. It's going to create the stack and then the network. And Pulumi, by the way, does eagerly create the resources. So basically, it does as much in parallel as it can. So in this Pulumi program, everything kind of depends on the network, right? The subnet and the cluster. So it can't create those things until after the network is created. But now you can see, okay, the network is created. Now it's dependent resource. The subnet is being created. And just like it's doing with this create, any changes you make in this program, Pulumi will figure out what to do in what order. And again, that is the declarative nature of Pulumi. So it's going to do its thing. I am not going. So GKE clusters take about like some 5 to 10 minutes or so to provision. So I'm not going to bore everybody with watching this timer tick away. What we're going to do is we're going to jump on over to another program that I have. Now, it is more or less identical to what we created in the from the template. And I'm going to clear this just in case. So at this point, this is what your program will look like. Again, everything has been created. And what we're going to do now that we have our cluster created, we can do a few things. So first, we can run the Pulumi stack output, which will give us a list of our outputs. So we have a kubeconfig in here, and you'll notice that its value is marked as secret. And this is one of Pulumi's coolest features. Pulumi is very, very good with security. Pulumi knows what values are secrets, but you can also specify additional secret values. And Pulumi will never, ever store your secrets in plain text on disk. It will use a Pulumi secrets provider. The default is the Pulumi cloud, but you can also use any of the secrets services, any of the encryption services in any of the major clouds. So what happens is behind the scenes, Pulumi says, oh, this is a secret. I'm going to send this off to my secrets provider and ask it to encrypt it. And then it will take the encrypted value and store that to disk. Now, in order to generate a kubeconfig, we are going to need to access that raw value. So I'm going to run Pulumi stack output kubeconfig with the --show-secrets option. And we're going to spit that out into kubeconfig.yml. So I'm not going to show you the contents of kubeconfig.yml, but I'll run an ll command just so you can see, yes, there is content in there. So there is a kubeconfig in there, and it does contain secrets. So what we're going to do now is we're going to export the kubeconfig environment variable equal to kubeconfig.yaml. And what this is going to do, except I typed it wrong. There we go. Okay, so what we're going to be able to do now is we're going to be able to run kubectl commands. Excuse me, kubectl. I've been informed that that is the official pronunciation. Kubectl commands against the cluster that we created in our Pulumi program. So again, that is our GKE cluster. which we have defined way up here. All right, so I'm going to actually make this full screen. I'm also going to clear. Okay, so now we can run commands against our cluster. So let's run kubectl get pods dash dash all dash namespaces. And so when we do this, you can see that, okay, well, here are all the pods running. And so we have nothing running outside the kube system namespace, right? Because this is a freshly created cluster. But we can see all the pods that are doing all the magic behind the scenes that makes GKE clusters so much easier to administer. Okay, well, that's great. But wouldn't it be better if we were able to deploy Kubernetes resources using Pulumi itself? And that is exactly what we're about to do. So the next thing that I need to do is install the Pulumi Kubernetes provider. Kubernetes. This has already been run on this. So this is already in my node modules. Oops, I probably spelled it wrong. Yes, I did. Okay. So it's already been installed in this particular program, but this would install it if you're running this fresh. So this will give us access to the Kubernetes provider. Okay, now let's go back up to our imports, and you would need to add this line, import star as Kate's from @Pulumi/Kubernetes. And the next thing we're going to need to do is, so we're going to need to initialize the Kubernetes provider. Normally, you don't need to do this. So you might notice, hey, we didn't need to initialize the GCP provider. Why do we need to new up a Kubernetes provider? Well, the reason for that is that we are creating the cluster in this Pulumi program. And so the kube config that we need to point the Kubernetes provider does not exist. If we wanted to, if we had different stacks, we could maybe take that kube config and make it an output and pull it in from another stack. So what we're going to do is we're going to const Kate's provider equals new.
While you're doing that, Josh, there's a question in the chat.
Yes.
Just from a previous point about secrets. Florian's wondering if it's possible to store secrets in Vault, for example, HashiCorp Vault, programmatically.
Absolutely, yes. So we the full range of secrets providers that we support we support the encryption services. It actually, by the way, does not store the secret in Vault. It uses Vault's encryption and decryption capabilities to encrypt and decrypt. The actual secrets, the ciphertext is stored in Pulumi. Now, that said, Pulumi also has a Vault provider that will allow you to pull secrets from Vault within your Pulumi program if you want to. You can also manage any of the various Vault objects that you want using the Vault provider. Okay, so we're going to new up this Kubernetes provider. And, oh, yes, I was remiss in not showing, by the way, folks, because you are using regular programming languages and regular libraries within your programming languages, you get the same IntelliSense and that you would get using any other library in your language. So you can see here's all of the options we have for creating a Kubernetes provider. One of which, by the way, is kind of interesting. So if you set this render to YAML directory, you can use Pulumi simply to template out manifests if that's what you want to use it for. We won't be demoing that today, but it is kind of a cool feature that can be very useful. So we're going to specify this kube config is equal to the kube config here. That's our cluster kube config. But now we're going to create some resources, and we're going to tell our resources to use this Kate's provider that we just created. So I'm going to copy and paste this part because writing these resources would be very hunt and peck. So we're going to deploy Nginx. We're going to make a kates.apps.v1 deployment. And that maps to exactly what you would expect. This is behind the scenes. This is a deployment object. And you'll notice that this follows the very similar, in fact, an identical object structure to what you would be doing in YAML. Only now you don't have to worry about indentation. If anyone here has worked with Kubernetes for any amount of time, I'm sure that you have been bitten by YAML's white space sensitivity. You'll also notice that again, you get all of the same IntelliSense completion that you would expect. So these are all, we had internally, we keep a schema of for each object, and that is reflected in autocomplete or IntelliSense in your editor. So you'll notice here that we are now using a third argument. So as I mentioned before, whenever you create a resource in Pulumi, each resource's arguments follow the same pattern. First, you have the name, which we're calling nginx deployment. Then you have the options for the resource, and this third set, the configuration for the resource, and the third are the options for the resource. And here we're telling this thing to Pulumi to create this particular object with a specific provider. Again, this is not you're not going to need to set this all the time, but it's good to understand that there are a list of options here. For example, if you are creating a database, you may want to set the protect. So protect will, for example, prevent a resource from being deleted. There's a whole list of different resource options. They are well documented. And if anyone wants to, I'll be happy to throw a link for that when we get to the Q&A portion. You may also want to, for example, use retain on delete, which will so if you set where are we here? Protect will cause an error if you try to delete it. Retain on delete will still execute the program, but it will leave the resource behind. At any rate, there are a range of options that you can set in the provider options. Most of the time you won't need them, but it's helpful to know that they are there. Okay, so this is our deployment object. Next, I'm going to create a service.
Just while you start that, Josh, there's another question in the chat, and it's quite a good one because we're talking specifically about TypeScript at the moment. But the question is index.ts like main.tf in the Terraform world? Is it possible to create modules and modular flow like in Terraform?
Yes and yes. So, depending on which language you're using, if you're using Python, it's __ main.py __, which is quite a mouthful. In C#, it would be program.cs. So that's what index.ts is. It's the entry point to your program. As far as modules go, there are a lot of different options in Pulumi. So if you want to use plain old classes and functions to modularize your code, you are more than welcome to do that. And that is a perfectly valid pattern. In fact, I would recommend that you just start with just using functions if you need to, for example, repeat things. By the way, because Pulumi uses real programming languages, you also have like all of the other normal programming language features at your disposal. You have for loops, you have if else, all that stuff is there and it will work as expected. So coming back to module options, we also have this concept called a component resource. An example, I don't think we're not using any component resources here, but if you wanted to, you could make a component resource that might encapsulate, say, a VPC and some subnets, or excuse me, a network and some subnetworks. So you can encapsulate things that way. Tim, if you could look up the docs for component resources and maybe throw that in the Q&A. And then we have like our most advanced way of encapsulating things, which is you can create actual multi-language components. So that's a very advanced feature. Most folks will not need to do that. But if you're in a very large organization and your Pulumi usage is very widespread, and we do have some of those customers, you can create Pulumi. You can create Pulumi multi-language components that include a schema and will be callable from any language. So that's like that's the full range of options for modularizing Pulumi code. And also, you can create packages that are in whatever your language of choice is. For example, if we're using TypeScript, so we can make an npm package that has all of your pre-approved configurations for, like, say, GKE clusters, and you can distribute that just as a regular old npm package, which is very, very powerful option.
Yeah, I was 100% going to get on the back of that. So I love Go. I spent a lot of time in Go. You can obviously do a lot of package and module work in Go, and it works really well because you're bound by the constructs of the native language, not just of Pulumi as a programming process itself. In addition to that, I think one of the things that's really cool is that because it's like it is using the real native languages under the hood, you can actually compile, like in the construct of Go, you can actually compile a binary, and you can even like store those binaries in your registry. So whether it's JFrog Artifactory or something like Google Cloud Artifact Registry, you could store those as artifacts versioned and tagged. And you could effectively roll forward and roll back an architecture or redeploy a particular version of an architecture, as long as you're cautious of your state objects where you're managing state outside of the binary itself.
Awesome. Okay, so back to our program. So we are now at the point where we're creating our service. So we've created our service, and the last thing we're going to need to do is we're going to need to create a stack output that gives us the IP of our Nginx installation. So again, the way that we do that is we do export const, because what we're going to do once we spin all of this up is we're going to verify that our Nginx has been spun up by curling the IP. So again, the command that we run is Pulumi up to deploy our infrastructure. It will give us a preview. If you ever want to skip the preview, there is a -y option. I would strongly encourage you not to use the -y option if you're working on production infrastructure, because it's very good to know what's going to happen before you agree to it. But what we have here is we are going to create this Kubernetes provider, because providers themselves are Pulumi resources. We are going to create, again, our service and our deployment for Nginx. And then once that is done, we will get our load balancer address. So let's say, yes, we want to perform this update. And it's going to do its thing. And again, this would be a great time. If any folks have any questions, please hop on over to the QA tab and we can get those answered for you. All right, so our deployment is up.
There is one here. Maybe you answered it already. Can we also run the Pulumi code without or with the programming language? Example, a Python web service to provision resources in the cloud and calls the Python code to create it.
So that is an excellent question, and the answer to that is also yes. So Pulumi has a feature called, all right, so you can see that, like, when I'm running these Pulumi programs, I'm using Pulumi up. So I'm running my Pulumi code through the Pulumi CLI. In addition to that, we also have a feature called the Pulumi Automation API, which basically flips that dependency and allows you to call Pulumi through your code. So it essentially flips the dependency. So in this case, we have Pulumi calling our application code, but when you use the Pulumi Automation API, it flips that dependency, and your code is just regular old Python code, or regular old Node code that is taking on Pulumi's dependency, and then you can perform Pulumi operations within your code. And so this is where you start to get into, like, some really fascinating possibilities. So you can hand off a CLI tool written in Go, let's say, that lets your development team spin up their own infrastructure. Excuse me. And that's where we really get into what the kids are calling platform engineering, where you have a centralized team that is making these tools available to your development teams with, like, all the guardrails installed, and it can be a major improvement in productivity. So we can see here that our Pulumi program is finished running, and we have our Nginx load balancer address, which I am. Oh, right. And so again, we can access these values by going Pulumi stack output, and typing's not the best today. Copy that. And so again, we can get this IP address. And what I'm going to do now is I'm going to maximize this window, and I'm going to run curl, and I'm going to curl this address. And I'm going to jump around a little bit. Got the HTTP : // So we run this. Lo and behold, we see the Nginx default page, and we have ourselves a working Nginx service. So this would be another good time to circle around for questions. Anyone have any questions on the stuff that we presented so far? I'll give that a few seconds for people to consider. But if there are no questions at this time, and Tim, keep me honest if there are, we're all clear.
We're all clear at the moment.
All right, very good. So what I'm going to do now is I'm going to show you all the real magic. This is Pulumi AI, and I need to reload the page. Pulumi AI, this is totally free. You can reach this at pulumi.com/AI, which is available on the handouts tab. And the way the Pulumi AI works is you can ask it a totally free-form question, and you can get real vague with it. Let's say, show me how to do something cool with Google Cloud Run. And so it will start to reply. And as you'll see very shortly after this preamble, which I actually learned the preamble. Why does it do the preamble instead of just giving you the answer? Because the preamble actually helps it give a better answer. The way that these tools work is they are essentially incredibly sophisticated autocomplete. And so giving this preamble kind of gets it in the right like frame of mind, so to speak. And so look at this. We have Pulumi AI writing us a Pulumi program. And so the way that this is really awesome. Like, so you can select whatever language you want to use, and it will generate that. Once it is done responding, since we have about half an hour left, we might even do this live. I might be feeling frisky, Tim. We might be doing some live code editing.
You're crazy.
Yeah. And by the way, if any folks are have questions, please ask, because I do love Pulumi AI, but it does take a minute to write out this question. So I would love to fill the time answering any questions that anyone might have. And please, don't be shy. We want to give you as much useful information as we possibly can. Okay, so we have our program here, and I'm going to, I think it might need to finish the response before I get that copy. Yeah, here's our copy button. All right, so let's do it. Give me 1 sec here, make a new window. Make sure Pulumi AI do it live. Okay. I'm going to fire Visual Studio Code, just as I did before. And I'm going to bring up a command prompt. And we're going to run Pulumi new TypeScript. So the Pulumi new TypeScript, by the way, will give us a totally blank TypeScript program. I see a question in the chat. Will we get a recording? Yes, you will. You will get an email within 1 to 2 days that will have the full video of this workshop, and you can go through it at your own pace. So yes. Okay. So now we have our pretty much blank TS. Let's install the Pulumi key library. Actually, yeah. And then I'm just going to paste in our output from Pulumi yes. Okay. So some interesting things here. We So it's not perfect, but what it will do is it will give you a very usable starting point. So what you can say is like, "Hey, I don't think that, let's see, so the repository ID is missing." So what you can do is you can go back to here and you can say, "Repository ID is required and missing from the artifact from the repository." Lo and behold, so if you can't read this, it says, "I understand that you need the repository ID to be included in the deployment. Here's the modified Pulumi TypeScript program with repository ID, my node repo for the artifact registry repository." And so like this is essentially how you're going to want to use Pulumi AI in practice. I'm not going to go through like the full spinning up of a program, but essentially it's kind of this feedback cycle, kind of wash, rinse, repeat, where you can paste the contents of the program, tell Pulumi AI, hey, this doesn't look right, or I'm getting this feedback from my IDE, and it will make the necessary corrections. Again, it's not perfect, but it is a really, really great way to get started, especially if you have like a use case that might not be covered by our examples, because Pulumi has such a huge range of providers. And I will just to give you a picture, pulumi.com/registry. You can see here that we have all the major cloud providers, but we have like there's 131 different packages in the registry, most of which, by the way, are for different cloud and SaaS services. So I'll do a quick scroll. You can see that there should be some familiar logos on there. So there's a lot that you can do with a single tool with Pulumi. And then the cool thing is that if you're, and it is perfectly normal, by the way, to use multiple providers in a single Pulumi program. Pulumi will orchestrate all of this infrastructure for you using a single tool.
So, Josh, just while you're taking a pause there is another question in the chat for you. It says, is there any hub for production-ready infra examples or best practice guides for production with Pulumi? I'm not sure if we're talking specifically about best practice with a particular cloud provider or a particular, Pulumi provider itself, but maybe just if you want to answer that.
So as far as practices for Pulumi itself, I'm going to grab this blog post. Please pardon my scrolling if it is making you dizzy. So we have a recommended practice series for. I'm going to put this in the answer. So we had for Pulumi practices, not specific to any cloud. We have this blog series called IAC Recommended Practices that you can use. It's very, very helpful. As far as the cloud goes, we do have some higher level abstractions for another major public cloud that is very large, and I won't name by name. We do not yet have that for Google Cloud, but we do have a pretty decent set of examples for most of the popular resources. And there are obviously a ton of resources in Google Cloud. And I'll make this a little larger. So this is the Pulumi registry. These are essentially the API docs. And you can see that if we go to cluster and select cluster, we do have examples that will sort of point you in the right direction. You can, between our examples, any prescriptive guidance that the cloud provider itself gives, and Pulumi AI, you should be able to get pretty good, pretty close to production ready infrastructure.
Yeah, I was just going to add on that, from the cloud point of view, from Google Cloud's point of view, right? When you're using something like Pulumi as a tool to orchestrate your infrastructure as code, we recommend, regardless of what provider you use, that you follow the best practices that the cloud provider lays out in their own documentation. So for us, that is how you handle the security of your secrets, or how you set up your secure pipelines for deployment of both infrastructure and or applications, your IAM permissions and everything. But what's amazing about Pulumi in its sense, or any infrastructure as code provider, is you can you can modify your infrastructure as code however you like. Actually deploying towards those best practices is something that you can put in place, whether it's through something like Pulumi policies, which is something we haven't really talked about today, but definitely recommend you should look at, or other processes. But in addition to that, the cool thing with Pulumi is you are talking about using real world programming languages, and they should go through any form of true code review. And so if you have internal best practices for how you use Go or TypeScript or Python, then you should also ensure that your Pulumi infrastructure as code adheres to those, so that you get the best out of your documentation, your dev workflows, your DevOps workflows, everything to your organization as well. So while Google have its recommendations for how you do implementation of our cloud resources, they will marry up with the fact that Pulumi can actually execute on those. And then on top of that, you can, because it's a real world programming language, you can apply your industry or the industry standards, your organization's best practices, and what do we call it? Code practices effectively to those language specific implementations as well.
Very good. So we have about 20 minutes left. If any folks have additional questions, now would be the time to ask, because I have presented everything that I want to show you fine folks. Actually, no, I have not. There's one more thing I want to show. Let me show you the Pulumi Cloud and what that brings. So Pulumi Cloud is the default backend. Again, it's doing your secrets management and your state file management, but it also has a wonderful UI. So we can go to this dashboard, and so this really shines when you start to use Pulumi, like at least at a team level, and you start to have collaboration. We get some nice widgets on the dashboard: the number of members in our organization, our total stacks, our total resources. You can see your resource count over time. Mine tends to go up and down because I am running workshops and deleting infrastructure.
Sorry to cut you off, Josh.
Mm-hmm.
Your screen is not sharing.
Oh, my screen is not shared. Oh,
I think
no.
you're showing beautiful things, and I think people should. Yeah.
Okay, so my apologies for that. So this is the Pulumi Cloud dashboard. You can see that we have member count, total stacks, total resources. You can favorite stacks, for example. We can keep our resource count over time. A nice overview of our organization's infrastructure usage. In addition to that, we can also click into any of our stacks. This is the one that I was working with today. On this page, we get an overview of our resources, for example. And we also get these handy dandy links that you can open these resources in your cloud console. Not every resource is supported, but like most of the most popular ones for the most popular clouds are. If we go to this activity tab, this is super helpful. So this gives us a list of all the changes that happened to our stack over time. So if we click into the details here, you'll notice here, and I will make this larger, that all of the output that we got on the command line is available in Pulumi Cloud. It's super duper helpful. We also get some contextual information on what Git repo we're using, what Git branch, and what revision. So this activity tab is super helpful at showing us who changed what when. Which, when you're dealing with longer running infrastructure, it's really, really helpful. We also have this new feature called resource search. This came out just I think a month ago or so. So if we wanted to look for everything we're doing with Kubernetes, let's go Kubernetes service. We can run that query, and we will get everything that is relating to that service. We could run GKE as a query, and then we'll see all of our. So the reason that this is showing is because the name of the project is GKE Node Pool, but it does do regular natural language search, and this is like a really nice new feature. Any questions on the stuff I'm showing so far? Okay. So there is one more thing I do want to demo, which is super important. The command to tear down your infrastructure. which is, and I will clear, whoops, are in the wrong. Okay, so this is our window where we demonstrated Nginx. So I'm going to clear. And the command to destroy your infrastructure is Pulumi destroy. And please, please, please remember to do this so you don't leave infrastructure up that you don't want running and incur unnecessary charges. So again, just like with Pulumi update, we get a preview. It's going to tell us what it's going to do. It's going to delete every resource in the stack and also the stack itself. So we're going to say yes. And then Pulumi is going to go off and do its thing and delete all the stuff that we created. This is going to take a little while to run, and so I'm not going to bore everybody with the with timer watching here, but it will destroy all the resource that you created. So if you're following along at home, that's very important to remember to do at the end. I see one more thing in the Q&A tab. Is there a way to play with Pulumi without using any cloud environments at all on your home server with Linux, Docker, Kubernetes? So we don't have a specific guide for that, but we have a Docker provider which will not interact with anything outside of your local file system if you tell it, for example, not to push the image. But you can also we have a Docker provider that would be suitable for that. We also have, and I can call this up. We have in our registry, we have what is called, I'll show you how you search. We have the command provider. And what the command provider does is it executes an arbitrary shell command. So that's another way that you could play with Pulumi. It's super useful. So if you go to the API docs, you can use the local command resource, and that will it will execute commands. It's actually super useful if a particular resource maybe is only supported from the command line. You can use the command provider to create or destroy the resource if you need to. The command provider also has the capability to execute remote commands over SSH, which can be useful if you need to do some provisioning steps on, say, a VM that you create. So that should answer that question. By the way, if you use the Kubernetes provider will work against any kube context. So if you give it a kube, if your shell's ambient kube context points to a local server, Pulumi does not care. All it does is work against the Kubernetes API, and it doesn't matter where that API is. So the Kubernetes provider is also an excellent way to try Pulumi without using any cloud resources.
I think this also works with the Docker provider as well.
Yes, that we have a Docker provider. It is pretty. We actually just released a version 4.0 that has some 4.2 apparently that has some really useful stuff, particularly around the container resource. This is like a massive improvement over version 3.0. So you can explore that if you want to use Pulumi without any cloud resources. We also on our website have Pulumi Learn, I believe, which is mostly this will help you learn Pulumi concepts without getting into any specific cloud providers. So there's a number of resources around that. I see another question. Is there any support for additional programming languages planned, like Dart, Rust, Kotlin, and Swift? I am not 100% sure, but all right, so there are no plans to add additional languages. It is possible, but I am not certain. And please follow up with me on the Pulumi community Slack, and I will be able to tell you for sure. I believe that Java support covers other JVM languages. It might cover other JVM languages, but I'm really not sure. So if you follow up with me on this community Slack, I will be able to get you the details on that. Okay, so it looks like unless there are any further questions. And it looks like there are not at this time. So some resources to help you continue your journey. If you would like to be, we have all of our workshops at pulumi.com/resources. If you would like to be notified of upcoming workshops, you can subscribe to our newsletter. We have a great getting started section in our documents at pulumi.com/doc/get started. We have an extensive list of examples. You can access some of those both through the registry. So our registry has like a bunch of how-to guides. Excuse me. Yes, the registry does. And I can show you that page for Google Cloud. If you just bear with for 1 second here. Okay, so I'm going to switch to my screen, which unfortunately is covered. Okay, so here is the Google Cloud homepage on the Pulumi registry. And you can see here that there are a decent number of how-to guides that are available in various languages that will teach you how to perform a lot of different, create a lot of different infrastructure architectures. And I've already shown you the Pulumi registry. That's where you can see the full list of providers that Pulumi works with. And so with that, I'd like to thank everybody for your time. Again, please stay in touch. We can, of course, be found on Twitter, but Tim and my handles are at the top of this slide. Please join the Pulumi community Slack. You can find that at slack.pulumi.com. We have some additional resources available on YouTube at Pulumi TV, and you can view the full set of our open source code that is all available. That includes, by the way, both the Pulumi engine, the Pulumi CLI, and all of our providers. That is all available at github.com/Pulumi. And with that, on behalf of Tim, I would like to thank everybody for your attention and have a lovely rest of your day. So long, everybody.
Ciao.